Figure 17.4, a three-panel figure. First of all, showing anomalies in sea surface temperature from 1880 through to 2020. And this is shown relative to the average sea surface temperature from 1971 to 2000. So that's the zero change horizon that you see in the diagram. So basically, prior to 1940, water temperature was much lower than the average between 1971 and 2000. And after 2000, we see a steady increase or positive deviation from this average value for the period 1971 to 2000. So a very clear and relentlessly increasing trend. Then in part B, here we see a more recent study where methodological variation was taken out of the calculation of ocean heat content and also sea surface temperature. Again, though, we see that the trend is generally upwards in a very consistent way post 1970, whether we're looking at sea surface temperature or ocean heat content. Interestingly, in this diagram also shown are major volcanic eruption events. These typically would spew considerable amounts of ash into the atmosphere, thereby screening energy from solar heat, and we see a reduction, generally speaking, in ocean heat following a major eruption event. So this shows the influence of some of these large-scale events on the climatic patterns that we see around the globe. And then finally, in panel C, we have a global view of what has happened to ocean temperatures, again on a relative scale, but the picture, generally speaking, is that ocean temperature wherever you go has increased, with the single exception of the North Atlantic to the south of Greenland, where ocean temperature has actually decreased. And this is due partly to the melting of the polar ice cap, introducing cold, less dense fresh water into the North Atlantic, and this fresh water, of course, sitting on top of the water underneath.